Hello, good afternoon, and Tashi Delay. Welcome everyone for the second session of the day. And the topic for the second session is um, the first. The first one is theory of everything and ultimate reality versus three levels of dependent origination, and how the true two truths are the same entity as interpreted by Prasangika Madhyamaka. And our second topic is intrinsic properties of microscopic entities and concept of emptiness versus distinctions between partless particles, indivisible particles, and intrinsic particles from Buddhist perspective. So I would like to warmly welcome our chairperson for the second session of the day, um, Venerable Geshe Samdela, Vice Chancellor of CIHTS, Central Institute of Higher Studies, Varanasi University, and our following guest speakers: Professor Satish K.S. from Transdisciplinary University, Bangalore; Professor Cecil Roy from National Institute of Advanced Studies, Bangalore; and Dr. Pooja Dobralla, Assistant Professor of the Department of Buddhist and Tibetan Studies, Namgyal Institute of Tibetology. And I would also like to make an apology on behalf of our guest speaker, Dr. Nilza Wangmula, since she couldn't make it today for the conference due to some concomitant engagements. So, with this, I would like to request Venerable Geshe Samdela to kindly come to the dais and occupy his honorable seat. Please welcome Gishla. And I would also like to welcome our guest speakers, Professor Satish KSG, Professor Cecil Roy ji, Dr. Pooja Dobral ji, to kindly take their respective seats. Thank you very much. Um, I would also like to make an announcement. Dr. Pooja Dabralla, she's on her way right now, so we'll be expecting her soon. Thank you. Gishing, I would like to request Gishing Samdila to kindly address the session.
The distinguished scientists and august audience. Now we are in this second technical session. It is on the ultimate reality in three levels of dependent origination. So, in continuation to what I have been saying this morning, that in Buddhist philosophy, Buddhist philosophical schools, you come here. There are four major philosophical schools, and the general idea is that the first two schools, they propose the selflessness of person, and the Mahayana schools, the Vijnanavada and Madhyamika schools, they propose the emptiness and selflessness of not only person but also the selflessness of phenomena. But when we look at the progressive evolution of the philosophical schools, then in the first, the Vaibhashika school, they reject the independent, unitary, and permanent self. But when in the Sautantrika school, then they reject the autonomous self, self-sufficient self, which is the owner of the aggregates. So it is much higher than what Vaibhashikas propose. But it is interesting to see that even though the Sautantrika is regarded to be not entering into the domain of selflessness of a phenomena, But it is interesting to see when in the course of their interaction with the Nayayika, Vaisheshika and Mimamsakas, they profusely negate the substantial existence of universality, universals such as differences, such as particulars, and such as um, the many of the samanyas, the universals, which are regarded as absolute in the view of the Nayayikas and Vaisheshikas, and they propose that these are mental constructs, not let alone being absolute. So in a way they have already started entering into the selflessness of the domain of the phenomena. So, and then after that you can see the the Vijnanvada, which exclusively rejects the external phenomena, the external material world, but they subscribe the existence of consciousness or mind as something substantially existent. And then when we reach into the domain of the Madhyamika, then again we find the two levels of Madhyamika. One is the Swatantrika Madhyamika and the other is the Prasangika Madhyamika. And in Prasangika Madhyamika, they reject the ultimate reality, ultimate nature, ultimately existence of the entities, but they are, they exist from the objective side. At the same time, they are designated from the subjective side. So with this kind of a union of subjective and objective kind of approach, the things exist. But when we enter into the domain of the Prasangika Madhyamika, then everything is rejected in terms of inherent existence, and every phenomena, either person or phenomena, are merely designated. Nothing exists substantially, nothing exists inherently, nothing exists concretely. So that is the highest level of Buddhist philosophy, where the shunyata at the ultimate level, at the highest level, is explained and demonstrated. So this is how in Prasangika Madhyamika it is, and in it is explained. Now the three levels of the dependent origination, like the causality, karya karan bhava. The karya karan bhava, as we have been listening since this morning, the it is applicable only with the composed phenomena, and it is not, of course, applicable to the non-composed phenomena. Sanskrit dharma, what we call in Sanskrit Sanskrit dharma. And then, of course, all the causes are, all the results are dependent on causes. But when you reach at the Prasangika level, even the causes are dependent on, the result. Effects are the causes. The hetu is dependent on the phala. Just as the father is designated in the context of having a son or daughter, otherwise that person doesn't become father or mother. So similarly, the fruits or the effects are dependent on the causes, unlike the earlier schools, they propose. Now, when we reach to the parts and the whole, or avayavi bhava in Sanskrit, then when we look at it, either at the gross level or at a very very subtle level, the avayava aviyavi bhava, the parts and whole, the dependent nature is very subtle and very profound, that nothing can be established without taking into the whole, and none of these whole can be accepted or established without taking into account the existence of the parts. And no parts can be, established without taking into account the holistic whole parts, right? So it is extremely interdependent. And when we come to the level of designation and simply things existing only at the level of designation, then everything is based on our mental and linguistic imposition and mental approach and conceptual approach. So these are the three different levels that and the three different levels of dependent arising. And as I mentioned earlier, the Prasangika Madhyamika's approach to Shunyata. So for many, and even the lower schools of the Vaibhashika and Sautantrika and the Vijnanavadas, from their perspective, if everything is empty, then how things can function? The tenability of the system of the things doesn't work, right? So that is why in Mula Madhyamika Karika they have said that Master Nagarjuna has stated that how they argue against the Madhyamikas, that if everything is empty, then nothing can work, nothing can function. Even the three jewels and four noble truths won't work. But Master Nagarjuna and the following Madhyamika masters, they turn the table around and then give the same argument against them, saying that if emptiness is not tenable, nothing can work, nothing would work. Everything would be self-existent, everything would be dependent. If they are dependent, how they would function? How these subsequent the evolutionary kind of events would take place. So therefore, in Master Nagarjuna's the Mula Madhyamika Karika, it is said, Sarvam cha yujyate tasya shunyata yasya yujyate. Sarvam na yujyate tasya shunyam yasya na yujyate. For whom to whom emptiness for whom to whom emptiness makes sense, everything makes sense. For whom to whom emptiness does not make sense, nothing makes sense. So this is the ultimate kind of perspective of Prasangika Madhyamika. So with these notes, I would like to invite the speakers of this session. First of all, I would like to introduce Professor Satish ji. Professor Satish ji has a wonderful combination. Professor Satish ji holds a doctorate degree from the University of Massachusetts, Amherst, USA. He is a founder director of the DEPA Solution Private Limited and a mentor at TAQ BIT Technologies Private Limited. He works with customers on solving real-life problems using fundamental physics and data science. Satish also holds the position of a professor emeritus at Transdisciplinary University. He has served as the chair of Computer Society of India, Bangalore chapter. His experience spans over two decades in IT industry, predominantly at HP and IBM. He has worked in the area of data science and its application in many domains. His current interest includes practical application of quantum technologies and application of MI and AI. Now, I would like to invite Professor Satish for your presentation. Thank you.
Namaste to everyone. And I feel humbled standing in front of and so many distinguished people on the dais who are deep into philosophy, and while my philosophical seekings are only questions and no answers, my background is more of a practical physicist. However, I'll try to put it in a perspective that will fit today's context. And to do that, I'm going to say some things that I have in the presentation and some things that I haven't written in the presentation. First and foremost, I would like to at least talk a few minutes about what I think is reality. Reality actually depends on the perceiver's position. Now, all through the centuries of civilization, we have been looking at our universe, trying to understand what it is telling us. In the beginning, we had access to only our senses, and our interaction with the universe is only our senses and our experiences through the senses. We've been asking those questions as to what these things mean. What do the stars tell us? What do the how does day and night happen? All these are questions that are relevant to our experience, our ability to see things. Now, as time went by, we started extending our senses by inventing new ways of looking at universe or extending our senses. For example, the telescope allowed us to see beyond what we could see before. The microscope allowed us to see things smaller than we could ever see before. So our reality got exposed beyond what we were able to see when we were only depending on our senses and not with the aid of technology to extend our senses. That is one aspect of reality, and that continues to date. And this has led us to believe, for instance, the way we have been doing things, if we want to look at, for example, what this bottle consists of, our instinct has been and continues to be break it up into smaller pieces, go to the smallest possible, and then we'll know how it is constructed. Everything is built out of whatever the smallest constituent of that is. And that is how we have been thinking about explaining or understanding our universe. And that, for example, led us to start to understand how atoms behave. Atoms were smashed. We started to realize there were smaller particles that made up the atom, and so on and so forth. We went all the way down to the particles that today we largely believe will be the final constituents of matter in the universe. And also the way they interact are things that have been more or less discovered. Now, here is a big problem. While we believe that everything small that we know will constitute the universe, is it really true? For example, simple questions like water, we all know, is a molecule consisting of two hydrogen atoms and an oxygen atom. Is there a concept of wetness for water molecule? Wetness is a property that arises out of many particles of water coming together. It is a so-called emergent property. And that is not something you can explain by looking at the properties of water molecules. So, are we really doing the right thing is also a question that we need to ask. And as I said, I'm not going to answer all of these questions, both because I may not have the answer, and that's the most likely explanation. And secondly, there is also the time factor. However, what I'll quickly go through is what do I, in this context, mean theory of everything, and give you a historical perspective as to why we believe the approach we're taking is going to lead us ultimately to the theory of everything. Now, where do we stand today? And I'll just go a little bit more into detail on one of the most successful understanding of the ultimate building blocks of the universe today, and then end with more questions than answers. And the first disclaimer I should have made, and I'm going to make it now, is what we are talking about today, or what I am going to talk about today, is hardly about 5% of the universe. It is well known, there is indirect proof that 95% of the universe is not something we understand. We don't even perceive it. And the way physicists like to codify this is by saying it's dark matter and dark energy. Dark is something we don't see, so we don't know anything about it. And nobody knows what it is. But we know its effects. We know that it is there, but we don't know what it is. So I'm ignoring all of the 95% and talk about barely 5% of the universe that we believe we understand, or we are arrogant enough to believe we understand. Here is a rather intriguing poem by Keats. The way we work, there is, he was talking about a Grecian urn, and he said not only do these urns, or not only do we understand things by our sensual ears, but also through the unheard and the unseen. And this is what really we've been able to do. That is, by extending our senses beyond what we could actually see, we are able to see things that we were not able to earlier see. And thus, we've been able to go far and beyond what our ancestors were able to do. So, what I'm going to be talking more about are the deities of no tone, that we don't hear those, but these are the things that let us understand the universe. What is a theory of everything? So really, what is a theory? A theory is a framework that helps you understand what you're seeing. If I see something and I want to understand, I want to explain how it is there, how it is interacting with me, how it came to be, etc. That is a theory. Like Professor Satish was saying, it's a thought experiment. It's a creative process that we try to understand from what we know before how this came to be. That is what a theory is. A theory of everything, obviously, is a theory that explains everything we know. And I want to emphasize the word we know. because we are not going to be even able to ask sensible questions about things we don't know. And like I mentioned about the dark matter, for example, or the dark energy, we know nothing about them except that they are there. That much is like he said, we are absolutely sure that it exists. But beyond that, we know nothing more. So it's a theory that is able to explain everything, and more importantly, it has the power to predict things that we haven't actually seen, but should be there if the theory is correct. And I'll take you through examples of how this has happened and why we believe such a thing is even possible. And the most important attribute of a theory of everything should be it should be simple, it should be beautiful. Whatever concept one has about beauty, and it is again something that has to be experienced. I can't sit here explaining what beauty is, but we do know when we see a beautiful thing that it is beautiful. And a theory of everything has to be beautiful and elegant. These are the attributes of a theory that we expect. So, like I said, I would like to give a historical perspective. In the time of Newton, it was assumed that an apple falling down to the earth is in no way related to the planets moving around the sun. By then, they knew that planets were actually moving around the sun and that it wasn't moving and not everything was moving around the earth. But they had, until then, never thought that the two phenomena were related. Newton's theory actually made it possible, gave a framework to understand both the phenomenon of an apple falling down from a tree to the earth and the earth going around the sun and various other planets moving around the sun is a manifestation of one and the same phenomenon, that is gravity. So this was the unification in some sense of ordinary distances, ordinary small objects versus huge objects like the earth, other planets and the sun and so on. This unification came about because he developed a theory of gravitation that in that day, when we knew whatever we knew, we could explain a large portion of our knowledge. Similarly, in the 19th century, they were familiar with the phenomenon of electricity and magnetism as two different entities, different kind of things. But Maxwell came along and said that actually the two are the same. He unified what seemed to be diverse phenomena, such as a magnet, which we all know has a north and a south pole, and a south pole repels another south pole and attracts a north pole, and so on. And electric charges are charges that don't have two poles like that. They're simple charges. And they behave completely differently from magnets. But Maxwell came along and said, if the two are actually manifestation of the same thing, there is no two different forces called magnetic force and electric force. There is electromagnetism. So this I am emphasizing because this thought process of unifying things has come into our ethos all through these centuries. If you come to the beginning of 20th century, when revolutionary thoughts started dominating physics, there was relativity that was developed by Einstein, and quantum mechanics was making its beginning. Quantum mechanics shook the very way we thought about how things behave. And relativity questioned our understanding of the space and the concept of space and time that we had hitherto assumed were the right things. Newton assumed an absolute time, that anywhere anything has one quantity called time. And Einstein changed all that and said, no, time is relative. Time isn't something you can take for granted. Now, these two phenomena were introduced to physics, and it became obvious that that was the right way to think about things. Now, when towards the later parts of 20th century, Dirac started looking at combining the two, because it was known that if you did not look at relativity seriously, you're only talking about partial truth, which means partial reality. So reality has to be consistent with Dirac's, with Einstein's relativity. So Dirac combined relativity and quantum mechanics and came up with a theory which is called relativistic quantum mechanics. And the beauty of this combination was that to be consistent, this theory required that there be an antiparticle for every particle. So an electron would have an antiparticle called positron. And nobody had seen such a particle then. And a few years, perhaps a decade later, such a particle was indeed discovered. So the beauty of this theory was that it was not only able to combine two diverse phenomena into one, it was able to predict the existence of something that had to be there for the theory to be consistent, which I may call it arrogance of Dirac, or call it his insight or his spiritual vision into the reality. Whatever it is, he was able to say that there has to be a particle called an antiparticle, and for the electron it happens to be a positron, and indeed a positron was detected. So this I would consider as a triumph of such unification. The reason why I'm continuing to emphasize on unification is that every time you see a phenomenon, if you have to come up with a theory to explain that phenomenon, that isn't a great state to be in. You don't want to have to look at something happening around you and seek to understand that particular thing. Whereas if you have one all-encompassing framework which will explain every phenomena you see, that is the ideal state, and that is the theory of reality that we are seeking. So, as I said, Dirac was able to predict the existence of antiparticles, and this would have to be considered as a triumph of modern thinking of physics. But then disaster occurred in the 1960s, when large number of particles were getting discovered. This approach of smashing particles to find out what they're made of led to a huge number of particles. These hundreds of particles that were being seen had to be brought under control, because there wasn't one consistent, simple, elegant theory that would explain all of that. So looking at this and explaining this became the occupation of many physicists in the 20th century. While that was happening, it was also discovered that nature doesn't have only, or what we believed as just electromagnetic force and gravitation, and if we brought those two together, we're all set, got another jolt. It turned out that there were more forces. There is a force called a weak force, and the strong force. Weak force is the one that makes it possible for the sun to produce the energy that we receive on the earth. And strong force are the forces that really hold together the nucleus of an atom. So now, from having one or two forces, we went now to 4 or 5 forces. So it became, as I said, the occupation of much of theoretical physics to try and understand these forces from one single framework. And this has been a remarkable success. But mind you, this is a remarkable success in a limited context, in the limited context of what we have been able to understand and what we've been able to see. That's the 5% of the universe that we actually see. And the biggest problem in all of this is that despite valiant attempts of numerous physicists, many much smarter than anyone you can think of, they have failed to unify gravity and these other forces. The other 4 forces, the so-called electromagnetic, weak, and strong forces, have been unified. There is a beautiful theory that not only has led to prediction of many things which have come true. One of the most famous in the most recent times being the Higgs particle. Higgs particle was something that was predicted more than 50 years back, and it was predicted because it had to exist if this theory was anywhere near being consistent. And it was discovered in 2014, in 2014, Higgs got a Nobel Prize for the discovery of the particle in CERN. So there is some hope, but the fact that we have not been able to bring together gravity, which explains the universe at large, that is, all the galaxies, the clusters of galaxies, the stars, their motion, etc., are explained by gravity, and quantum explains the micro world. The approach of particle physics is to explain the micro world, and in between there is this reality of the emergent phenomena which happens because of multiple of these coming together, which remains still an area that we are hazy about. So, in conclusion, I would say that we're not there yet. We don't, let alone having a theory of ultimate theory of reality, we don't even know what exists in reality. And hopefully soon we will get there. There is every hope. And all of this really exposes us to the beauty of nature, beauty of mathematics that can understand this nature. Thank you very much.
We will have the opportunity for questions at the end of the session. Now I would like to invite Professor C.C. Roy. For him, introduction is not required. Prior to that, we have Nirza Varma to speak on two truths, but she could not attend. So now I would like to request Professor C.C. Roy ji.
Okay. Good afternoon, everybody. Maybe many of us are sleeping. We have taken good lunch, and I'll speak now intrinsic properties of the entities in the microscopic world and the concept of emptiness in Buddhism. Here, my presentation will more focus on the questions. I mean, I'm trying to present you some of the challenging issues which we don't understand. Maybe the eminent Buddhist scholars here, they can enlighten us. So I will mainly focus on the issues we are facing in understanding some of the outstanding problems in modern physics. So here you see that there is an image, and many people think that as soon as we go from bigger object to smaller and smaller object, called top-down approach, then entities like electron, protons, or like Higgs bosons, they are not like other particles, and they are something else. They say sometimes subtle particle, subtle matter, which is different from gross matter. But here we say that we are showing a picture where these entities are passing through a instrument called cloud chamber. This is like you take the photograph like. So here you can see the track or trajectory of the different entities, and from these track you can determine their properties. Similarly, in Higgs boson, big Large Hadron Collider in CERN, they also detected particle like Higgs boson from this kind of experimentation. So these are not like fictitious, somebody say particle or energy, no. These are real entities. Now if you ask me, what are the properties of the entities in the microscopic world? We can say that its mass, there is another attribute called spin, charge, or some other quantum numbers or some other attributes. So what is meant by intrinsic properties? In any kind of textbook in quantum theory, they have written that spin, that attribute is intrinsic property of matter. So we have an understanding what we call intrinsic property, and the philosophers in Buddhist philosophy too, they have an understanding what is this intrinsic property, or in Sanskrit called svabhava. And so as we discuss intrinsic property, there should be extrinsic property, that is called prabhava. So the intrinsic property in quantum theory, what we in any standard textbook we say, whether they're really intrinsic according to Buddhist philosophy or they are different. Say for example, in case of electron is a charged particle. It has a definite rest mass, it has definite charge, it has definite spin, and they obey particular type of statistics. I mean, if you look at the distribution of the electron, then you can determine their particular distribution of electron, called electron is a type of category of particle which is called Fermi-Dirac particle, and the light quanta or photon or some other particles which has different spin, they obey different type of statistics, that is called bosons, in the name of Indian scientist Satyendranath Bose. So what is meant by extrinsic property? Extrinsic property like weight, or like volume, or like orbital angular momentum. Orbital angular momentum, say an electron is moving in an orbit around a center called nucleus of an atom. Like around the sun, we have planetary systems. So on the basis of that kind of model, Niels Bohr proposed a atom model where inside there is nucleus and outside in the different orbits electrons are moving. There you can define orbital angular momentum. So they are called extrinsic property. And also there are some constants in nature called fundamental constants. One is Planck constant, it has a definite value. Another is gravitational constant, and another is speed of light. So these three constants called fundamental constants of nature. I mean, you won't get the value of, say, Planck constant here in Delhi and in Houston, in Texas. They are not different. Wherever you measure, you get the same mass, or like the same numerical value, similar to speed of light, 3 into 10 to the power 10 centimeter per second. This value, whether you measure here or in Bangalore or in Europe or in USA, you will get the same numerical values. These are called fundamental constants. Now, the issue is that what we call intrinsic property, like charge, mass, or spin, whether they can be changed or it is their intrinsic attributes. In the sense, if you consider any kind of process, say electrons and its antiparticle, what Professor Satish was telling, Dirac discovered is positron. Positron has opposite charge of electron. It has the same spin, but it has same mass. Now, if one electron and positron collide each other, it will give rise to energy, or what we call gamma or photon quanta. But again, if you start with the energy gamma, photon quanta, you will get electron and positron. So the same electron which has spin half or mass is a fixed numerical value. So even with any kind of transformation, you won't get different values. And that's why we say these are the intrinsic properties. Now, regarding fundamental constants. The fundamental constants, I said, the Planck constant, gravitation constant, and speed of light. So these values, wherever you measure in the universe, you will get the same value. But there is a little twist in this picture. If you accept that quantum theory is a theory which is valid all over the universe, then quantum theory says that you can get a probability distribution of speed of light. C can take many values, or H can take many values. Maybe for this universe, we have a fixed value of speed of the constant or fixed value of Planck constant. But in that case, we have to consider that there exist multiverse, different universes. I don't know whether in Buddhist philosophy we have the concept of multiverse. Otherwise, we have this fixed numerical value, which is very difficult to understand within Buddhist philosophical framework. And as I said, that intrinsic property and quantum physics. In quantum physics, basically, there are two categories of the entities or particles. One is fermion, another is bosons. Fermions, they have particular type of spin value, and boson, they have particular type of spin value. You cannot convert one boson into fermion or one fermion into bosons. I mean, you cannot change the value of the spin of the electron, say it is half, but you cannot change it to 3 by 2 or something else. So in the same electron, you will get always in the universe the same spin value or same mass value, I mean numerical value, or same charge. Now, emptiness and intrinsic property. The notion of interdependence leads us directly to the idea of emptiness in Buddhism, which does not mean nothingness. I mean, it is already told by Samtenji and other eminent Buddhist scholars. But what they say is the absence of inherent existence. But here, in quantum physics, we have the entities which have intrinsic properties or inherent existence. So I don't know how to reconcile with the concept of intrinsic property in quantum theory as well as in Buddhism. And now, say, we come to Nagarjuna philosophy, that the famous text Mulo Madhyamikarika. Nagarjuna's philosophy consists predominantly of two aspects. One is exposition of the concept of reality or shunyata, according to which fundamental reality does not consist of independent substantial components, that is absence of sabhava, and which is contrary to the thoughts which we have in quantum theory. So we don't know how we can reconcile with quantum theory. Then quantum entanglement and non-locality. I mean, one of our speakers is there who is going to speak on quantum entanglement and non-locality. Some experiment, initially, Einstein, Podolsky, and Rosen, they proposed a Gedanken experiment, thought experiment, by which they said that two particles of the same nature, when they combine together, but if they are separated miles and miles after, like the first experimental test was done in Switzerland under Geneva Lake by Nicolas Gichon and his collaborators, that even if they separated two particles apart around 16 kilometers or 12 kilometers, I can remember, even it seems they have a correlation between the two. But this correlation has to be produced by the experiment like this. You take first, say, two electrons, and now you make a state of the two electrons with some experiments, and then you are separating the two electrons far apart, and you are getting then the correlation. So people say it is related or it is analogous to concept of interdependence. But the issue is much deeper. Here there is no correlation exists between electrons and proton or electrons and photons. That kind of correlation is not, or non-locality is not there. So if non-locality is a universal property, then when you make a statement, the concept of interdependence is there also in the physical universe. I mean, not I am saying in Buddhist philosophy, I am saying in physics, because there is a school of thought called Itacha interpretation by David Marmin and his collaborator. They say that this kind of correlations or non-locality exist all over the universe. But we are saying, first thing, to study this correlation, you need an experiment. Experimentally, you force the two entities in a particular state, then you can see only kind of correlation. Not only that, that correlation exists among not all the entities, very particular type of entities. So this kind of special situation, we need to think in the context of Buddhist philosophy, where they talk about pratitya samutpada or like that. Again, the quantum entanglement or non-locality and the relational property. So in philosophy, in Buddhist philosophy, they say there is a relation which can be thought of intrinsic also, intrinsic relation. There is intrinsic relation and extrinsic relation. I don't know much about that. Maybe Buddhist scholars can elaborate on this issue. Why I am saying that when the two electrons or two photons are separated and it seems they are correlated, called non-local correlations, so that is basically a relation. And now relations between two entities, they are called relata or relatum, the single and the relation and relata, they are called, it constitutes a relation. And very famous Buddhist scholar, Dharmakritti, his book, Sambandha Pariksha, or Examination of the Relation, where he ultimately claimed that in the final analysis, relation is not real. But in case of quantum theory, the entanglement has proven to exist through laboratory experiments. So I don't know. Many Hindu scholars, they also had a great debate with Dharmakirti's work, even in Jain philosopher Prabhachandra and others. So we need to study how far this kind of philosophy of relation will be compatible with our present understanding of quantum non-locality or non-local correlations. Yeah. As I said, the Dharmakritti and his famous book Sambandha Pariksha, but there is a great debate, and people in the West, they are studying the philosophy or philosophy of relation from the study of Western philosophical perspective, but we should seriously study from Buddhist perspective, and of course the opponents of the Buddhist philosophers. So I can say that we can think of a possible dialogue. In quantum theory, on the one hand, we have intrinsic property, which has been found from various experimental situations. Now, in Buddhist philosophy, there is concept of emptiness. Emptiness means that absence of svabhava or absence of intrinsic property. But in our case, we don't have ultimate reality and conventional reality. That kind of gradation or layers of reality we don't have. So we have to critically examine this kind of things, and then we have to think of quantum entanglement and non-local relations, which should be which are proved to be real because they have found in laboratory experiments in recent times, where the quantum teleportation has found, or has, even in Chinese scientists, they have done experiments where they found a correlation of an entity in satellite and one entity in the Earth, and they found there is a correlation called non-local correlations. So this is because due to quantum entanglement. So quantum entanglement is real in case of quantum physics, and according to Dharmakirti, it should not be real in the ultimate sense. So few things I am emphasizing. One, when not only Buddhist philosophy, some other philosophy say that concept of subtle matter and gross matter. What is meant by subtle matter and gross matter in connections with the modern scientific paradigm? So far, we don't know it. Second is the intrinsic property in quantum theory and emptiness in Buddhism. And then the philosophy of relations and what the laboratory experiments say in modern physics. So these are the possible issues. We can have a dialogue with Buddhist scholars and modern scientists. Thank you.
Thank you, Professor Sisiraiji. You have proposed many avenues for dialogue between scientists and Buddhist philosophers. Now, I would like to invite and before that introduce Dr. Pooja Debral. She is an assistant professor in the Department of Buddhist and Tibetan Studies at the Namgyal Institute of Tibetology, Gangtok, Sikkim. Her doctoral research topic is Nagarjuna's philosophy of emptiness and Tsongkhapa's exposition. Descent in two prolific periods, these two, the earlier ones. She has teaching and research experience with a range of institutions, including the University of Delhi, Jawaharlal Nehru University, Tibet House, YMCA. Pooja has numerous publications and also presented papers on the themes of such as practice of emptiness, Buddhist approach to inner and world peace, Buddhist psychology, forms and substances in Buddhist philosophy, and so forth at national and international conferences and seminars. She is proficient. She is proficient in Tibetan and German, and has taught the latter for many years at the University of Delhi and other institutions. Now, Dr. Pooja Devar, please.
Hello, good afternoon. Can you hear me? Okay, thank you. So let me begin by thanking most respected Venerable Geshe Naman Santalla for kindly introducing me to our audience. So, and then also I feel very honored and privileged to share dais with two eminent speakers, Professor Satish ji and Professor Shisi Roy ji. And also I would like to thank Venerable Geshe Doji Damdullah and Tibet House for giving me this opportunity. So my topic for today's talk is distinction between partless particle, indivisible particle, and intrinsic particle from Buddhist perspective. So I'll be sharing the Buddhist perspective on particles, and I'll try my best to go to the nuances, although the time is very limited. Okay, so let me begin by what, I think we all will agree with what Buddha Shakyamuni said in many of the treatises and many of the discourses. If I may paraphrase his words, he said that the happiness that we all yearn for can never be grounded on ignorance. Rather, it always is a result of the correct understanding of the reality of ourself and the universe that we live in. So with that purpose, he taught the reality of the universe in a very extensive form, and also in the commentarial treatises, not only in the scriptures, Buddhist scriptures that come directly from the Buddhas, but also in the later commentarial scriptures, we find an extensive explanation of the reality of the universe, and especially when it comes to the physical universe. Okay, and then before I go to my topic, okay, so just a clarification here, we know that anything that exists is defined as a phenomena, and my topic revolves around the physical matter, but this is not the universe is not something which is confined to only the physical matter. In fact, anything that exists, as I said, it is known as phenomena, and the phenomena can broadly be classified under two major categories: composite phenomena and the non-composite one. So the composite are the impermanent phenomena which change momentarily, whereas the non-composite one are the phenomena that exist but are devoid of change. And then within the composite phenomena means they change momentarily. We have three major categories. Again, physical form, mind, and non-associated compositional factor. I'm sorry for the slide. It changed a bit, maybe different interface. Okay, so it's the third one is non-associated compositional factors. So the form, so my topic is around this physical form or the physical matter, whose fundamental building blocks we call is particle. So therefore the topic is particle itself. And before I go there, so let me just define the form as it is defined in many of the Buddhist treatises. It is said that form is something which is consist of atomically composed things. So here the word atomically, don't take it literally as it is accepted in physics, but it simply means particles. So something composed of particles, we call it physical matter or physical form. So within this category falls many phenomena such as elementary particles, and then the objects of our five senses, and then also the four great elements, and also the five physical sense power, which is so unique of the Buddhist perspective. And then in the mind category, we'll see that there is a again impermanent phenomena such as our own mind and the various functions of the mind, which we call mental factors. Then in the third category, it's a very interesting one. So anything which is composite or anything which is impermanent in nature but does not belong or does not fall to the category of form, or mind should fall to the category of non-associated compositional factor. And then the non-composite one means, as I said, something that exists but is devoid of change. So now the topic of today's talk is around form. Okay, and then as I said, form is something which is consist of particles, or we say that the fundamental building blocks of this physical matter that we experience through our five senses, such as sound, smell, taste, tangibility, and visual forms such as this mic, flower, this hall, they all consist of the particles as their fundamental building blocks. So to really understand the notion of the particle as comes from the Buddhist perspective, we should be going into the details of the four schools of Buddhist metaphysics, namely Vaibhashika, Sautrantika, Chittamatra, and Madhyamika. And within Madhyamika, again, we have two that I'll be explaining a little later. So now, the first two schools, Vaibhashika and Sautrantika, although they do not accord in all their presentations of tenets, but there is something which they accept unanimously, that is the acceptance, that is accepting something called partless particle. So what they say is that the physical matter that we experience around us, the fundamental building blocks is not only particle, they call it partless particle. And what is that partless? So as you can see, it comes from Acharya Vasubandhu's Abhidharma Kosh, Treasury of Higher Knowledge. A partless particle, a syllable, and a single moment are the smallest unit of matters or world and time. So if we just focus on the smallest unit of matter, the text says it's partless particle. And then what are the different qualities and the features of this partless particle? Again, one of the earliest Buddhist sources, the Katyayani Putra's great treatise on differentiation, enumerates several traits of this partless particle. Let me read it for you. First is the partless particle is the finest or smallest constituent of matter. Number two, it has no spatial dimensions because it's partless. Number three, it never exists on its own, but only in combination of other particles. And it is composed of at least 8 substances. What are these 8 substances? So the text says it is composed of 4 great elements: earth, water, fire, and wind, and the element derivative of form, smell, taste, and tangibility. So this is the description of the partless particle, which is accepted by first two schools, Vaibhashika and Sautrantika. Okay, now before I go into partless particle more, how these great elements, finally a partless particle, as we now understood that a partless particle should be composed of 8 substances, and out of those 8 substances, 4 are great elements. 4 great elements: earth, water, fire, and air, and the 4 element derivative. So the 4 great elements, what are the essential nature of these great elements and what are the function of these great elements? Again, the text says, so earth element, as you can say, that the solidity is the essential nature and the function is to support. Then the water element, moistness, and the function is to bind. Then the fire element, the essential nature is warmth and the function is to mature or ripen. And then the wind element, the essential nature is said to be lightness and the mobility, and the function is mobility given to the particle. And then why they are called great, there is a reason for it. As it is said, they are great in that they are found in all the matter. In simple terms, all physical matter that we experience with our senses, they are composed of particles, and again these particles, they have the great elements, so they become the support for everything that we experience as a physical matter. So therefore they are called great or maha. Then why they are called elements? Because they are the ultimate constituents of everything within the physical world. Okay, before I again go to the other Buddhist school's presentation of the particle, let me explain this also. This is something interesting that again comes from Buddha's sutras and the later commentaries on the sutras. So this is known as principle of atomic agglomeration. So basically to the question of that how from this very minute partless particles or from these elementary particles which are microscopic in nature, how this macroscopic physical world comes into being. So in the scriptures and the commentarial treatises, there is a mention of principle of atomic agglomeration, means how from the micro elements the macroscopic physical world comes into being. So in Extensive Display Sutra, this is Buddha's discourse, and also in Abhidharma Kosh, which is a treatise written by Acharya Vasubandhu, so there is a mention of the atomic agglomeration that proceeds by the sevenfold increment. So as you can see on the slide, it simply means how, the smaller particles, they make a bigger particle when it come in combination. For example, the 7 subtle or partless particle, they make one minute particle. Then again, one minute particle makes one subtle particle, and so forth. And then again, you must be wondering why this number 7. So this number 7 is just referring to how these particles are arranged. So 7, like for example, the one particle in center, 4 in the 4 cardinal direction, 1 above and 1 below. So therefore, the principal name is principle of atomic agglomeration, which increases by the sevenfold increment. Okay, so on the basis of this principle of atomic agglomeration, in these treatises, especially in Abhidharma Kosh, you will find a mention of the physical dimensions of sun ray particle, dust particle, particle of the rabbit ear, like this. So this is something that we can refer to if we want to know more of the principle of atomic agglomeration as explained in the Buddhist treatises. Okay, and then just to mention that this is not the only principle that is mentioned. In fact, there is a mention of the principle of atomic agglomeration, which increases by the sixfold increment. So different presentations are there that one can see in the treatises, Buddhist treatises. Okay, so now what we learned is that from the Vaibhashika and Sautantrika perspective, physical matter is finally composed of the particles, and then the final particle, they call it a partless particles. And then, but according to the higher Buddhist schools, namely Chittamatra and Madhyamika, and within Madhyamika, again, we have Swatantrika Madhyamika and Prasangika Madhyamika. They also accept that particles, okay, this is something commonly accepted by all the schools, that particles are the building blocks of physical world, number one. Number two, now here they differ. They say particles have parts. In other words, they reject the partless particles. So when it comes to higher Buddhist schools or higher schools of Buddhist metaphysics, they reject the presence of the partless particle. And how it is rejected, so there are different presentations available in the treatises. For example, in Acharya Aryadevas, who is a 2nd century great Nalanda scholar, who was a direct student of Arya Nagarjuna, and also a well-known formulation of the rejection of partless particle is found in Acharya Vasubandhu's 20th stanza Vimshatika. So here Acharya Vasubandhu argues that however minute a particle, so this is a presentation which is accepted by the higher Buddhist school. So let me clarify once again, they accept particles but do not accept partless particle. And the reason comes, a very rational reason is coming from the Acharya Vasubandhu's treatises. So before I read this, let me just quickly explain this to you, and then I'll be reading the verse. So Acharya Vasubandhu is arguing that however minute a particle is, it should have parts. Why? Because he gives the example. Let's say this mic, if we go a little closer to the mic, we'll all agree that it is made of millions and trillions of particles. In science, you may call it electron, proton, neutron. Let's say they are composed of millions of particles. And then from this pool of particles, if you just point one of the particle as the central particle. So let me clarify again. None of the particle is central with respect to other particles that are surrounding it. So let's say you mark one particle as the central particle, and then Acharya Vasubandhu says that this particle must be, let's say, it must be surrounded by 6 other particles, right? And the very fact that this particle is surrounded by 6 other particles is a clear indication that the central particles has 6 parts within. But when this is said, then the proponents of the lower school, Vaibhashika and Sautantrika, they were not very happy. And they said, yes, we also agree that the central particle should be surrounded by some particle, let's say 6 particles, 4 particles in the 4 cardinal direction, 1 above and 1 below. But it does not mean that this central particle is surrounded by 6 other particles, then it should have the 6 parts within. So to that, again, Acharya Vasubandhu rebuts by giving very rational reasoning, saying that okay, let's say if you say that it is the central particle is surrounded, okay, just to explain it more clearly, let me use this diagram. And one clarification, that this diagram appears nowhere in the Buddhist treatises. It just I picked up to make things clear for the audience. So here, if you can see, it shows the arrangement of the central particle and the surrounding 6 particles. So let's say when this is the arrangement, so Acharya Vasubandhu is saying, so this central orange particle is surrounded by the 6 particles. It's a clear indication that it has at least 6 parts, right? So it cannot be partless. But then the opponents, or let's say the lower Buddhist schools, they say, no, this does not prove anything. Why? Because although the particles are surrounded by the other particles, but it doesn't mean that they have 6 parts within. So then Acharya Vasubandhu gives more reasoning, saying that, okay, let's say if what you said is accepted, then there is an absurdity, there is an absurd consequence of that statement. Why? Because if you say that this central particle, orange particle, does not have parts within, then the orange particle, as we can see, touches the green particle in above, and does not. Okay, so orange particle has a part which touches the particle in the particle above, but not, or let's say particle in north direction, but not the particle in the south direction. And then, but if you say that, okay, it has a, so it's a clear indication that it has a part which touches the particle in the north direction, but not the south direction. And if you say that, okay, no, it does not have a part, then the same side or the part of the orange particle, central particle, should be touching the particle in the north as well as the particle in the south. If that is accepted, what is the problem? That the particle in the north and the particle in the south, they too will meet. Why? Because there are no 2 parts of the orange particle or the central particle which touches them separately. So now he says that the very fact that the orange or the central particle has a part which touches the north particle in the north and does not touch the particle in the south is a clear indication that it has 2 parts within. So and if that is not accepted and we accept what you said, then the same side or the part of the partless, which is partless particle, should be touching the particle in the north and particle in the south. Then the particle in the north and the particle in the south, they too will meet, and the central particle will disappear. And then you keep on doing this. If you go by this reasoning, then all the surrounding particles, they will keep on conflating into each other. And then we all will agree that we see the difference in the size of a mountain and the size of a particle because of the size. And why such a difference is seen? Because the particle within a mountain, they do not conflate into each other, right? So, but if we accept the partless particle, then the surrounding particles will keep on conflating into each other. Then you cannot account for the macroscopic huge physical matter. So now I'll read the verse. It should make little sense to us. Okay, so it comes from Acharya Vasubandhu's 20th stanza, a text written by him. It says, because of being simultaneously surrounded by 6 other particles, the central subtle particle is found to have 6 parts. If these 6 parts have the same spatial dimension, a massive object will conflate into a size of just a minute particle. So as I explained, if we accept a particle to not to have any parts, then the surrounding particles will keep on conflating into each other, because the central particle does not have the parts which touches them on different sides, because it does not have any parts. Okay, so with that, he rejects the concept of the partless particle. So this is something which is accepted by higher schools, the Chittamatra school and the Madhyamika school. Within Madhyamika, 2, Swatantrika Madhyamik and Prasangik Madhyamik. Okay, so now before I go to Madhyamika school, which is the highest Buddhist school, it is not highest because of any hierarchy or something. It is highest because it presents the subtlest of the ontological reality or the ultimate reality of the phenomena. Okay, so now Chittamatra, before I go to Madhyamika, so Chittamatra fundamental philosophy is, Chittamatra on the mind of the school, the fundamental philosophy is that everything is the nature of your own mind. Nothing exists external to the mind. So this is their fundamental philosophy, that everything is the nature of our own mind and nothing exists external to the mind. So then, do they accept physical matter or not? So within Chittamatra, scholars differ, of course. Some scholars say that the very fact everything is just the nature of the mind, you cannot accept particles to have any physical substance. Whereas some scholars, they make a distinction between physicality and externality. They say that although things do not have external existence, or particles do not exist external to the mind, but they do exist as particles, and they have the same traits as explained by the lower schools. Means they are the building blocks of the higher, they are the building blocks of the microscopic physical matter. At the same time, they are composed of 8 substances. So within Chittamatra, the scholars differ. And then next we have the Madhyamika school. So within Madhyamika we have two, Swatantrika Madhyamika and Prasangika Madhyamika. So Swatantrika Madhyamika in English is the autonomy middle way school. So this school accepts that the fundamental philosophy is the emptiness of true existence, means nothing exists truly. Right? So they accept that everything exists, as Venerable Geshe-la was explaining in his opening note, that they accept that everything exists by, partly from the object and partly from the mental imputation or the subject side. So this is their philosophy. And again, do they accept partless particle? As I said, they reject the partless particle, but they do accept particle as the building blocks of the physical matter. And then within Swatantrika, again, there are nuances. Since the time doesn't allow, I may have to rush. That within Swatantrika, there are divisions. Some are in line with the position of the Sautantrika school, second school, and some explain the physical matter in line with Chittamatra or Yogacara school. Okay, now I finally come to the Prasangika Madhyamika. As I said, is the highest Buddhist school for the reason it presents the subtlest of the ontological reality or the ultimate reality of the phenomena. So, and this also, before I go there, let me just make a clarification here that as we can see, partless particle versus indivisible particle. So part of my topic is also related to the indivisible particle. So as I said that Acharya Vasubandhu rejects the existence of the partless particle. Then what about the indivisible particle which are accepted in physics today? For example, let me say that quarks is accepted to be indivisible at the moment. But then if you accept the particle, if you do not accept the partless particle, what is the position on indivisible particle? So here I would like to share that there is no contradiction when it comes to rejecting partless particle and accepting indivisible particle as accepted in physics, because the indivisible particle as physics presents is a particle which you cannot physically divide. At the moment, you cannot physically divide it into parts, right? But Acharya Vasubandhu's rationality and the reasoning is that however minute a particle is, at the moment indivisible particle, but mentally you can always divide it into its parts because of the reasoning that I shared just now. Okay. Now the next is the final part of my topic is intrinsic particle. So here, why did I bring the Prasangika position is except for all other Buddhist schools, Vaibhashika, Sautantrika, Chittamatra and Swatantrika Madhyamika, it's only Prasangika Madhyamika which refutes the existence of intrinsic particle. All other schools, they accept that particles exist, be it partless particle or parts having parts, but that exists intrinsically. So they accept that things exist the way they appear to us as so intrinsically real. So likewise, these particles also exist intrinsically. But the Prasangika, which presents the subtlest of the ultimate reality of phenomena, they say that particles do exist, things do physical matter is composed of particles, but ultimately they do not have any intrinsic nature. So as Professor Sisi Roy ji, brought up many of the questions. So these questions can only be resolved in the Buddhist perspective when you talk about the two truths, that okay, conventional truth and the ultimate truths, and you see the harmony of these two truths. So what is being said by Prasangika Madhyamika is not that the particles do not exist. If that is accepted, then how are we using this microphone? So the particles do exist, but they do not, but when you analyze these particles closely, crossing the border of convention, meaning you subject the particles to ultimate analysis to find out, with the purpose to find out the ultimate nature of these particles, you will be amazed to see that they do not have any intrinsic nature. And for that, Arya Nagarjuna's Mul Madhyamika Karika has many reasoning. Here I cited Arya Nagarjuna's another text, which is Precious Garland on Ratnavali. It does not talk about the conventional nature of the particle. As I said, conventionally, in fact, Prasangika will accept the way science accepts that, okay, particles, whichever, dimensions of the particles is shared in science, they will accept it. But what is the ultimate nature of these particles? Then they come up with the theory that, okay, ultimately, nothing exists intrinsically. The very fact, in fact, if I may cite this statement, that emptiness of intrinsicality is the intrinsicality of the object. So in other words, that nothing exists intrinsically, it is the intrinsic property of the phenomena. So here in Precious Garland, Arya Nagarjuna said this, he was analyzing the person, the self, which interacts with phenomena, and then all the experiences come into being. So when analyzing a person, ultimately, how this person, does the person exist the way it appear to us? He gave us the reasoning that if the person is not earth, water, fire, not air, not space, not also consciousness, and not all of them, where is the person out of those? So basically, here the question is not about whether the person exists or not. If you are still not over of this question, then you are not doing the ultimate analysis of the person. First, everybody accepts that the person exists, but then the question comes, how does it exist? When the question is out, how does it exist? Does it exist the way it appears to us as from the object, or does it exist subjectively through the mental imputation? Then where you are subjecting the person to ultimate analysis. So then Arya Nagarjuna said, the very fact when you go closer to the person, and the person is composed of 6 elements, and none of the 6 elements is the person, and you do not find a person which is different from these 6 elements, is a clear indication that the person does exist, but it does not exist the way it appears to us. It's only by dependence on the subjective imputation that the person makes a sense, and not from the object side. Because if the person does exist from the object side, the more you go closer to the object, you should, or the person, you should be able to find the person. So in the same line of reasoning, he said we should extrapolate to see the nature of the particles or elements. So the next verse, it says, just as a person is not truly existent or intrinsically existent because of being an aggregation of the 6 elements, each element also is not truly existent because they are the aggregation of their own constituents. So the very fact that particles are composed of subatomic particles, when you go closer to the particles, if you don't analyze the particles through ultimate analysis and remain on the level of conventionality, then every feature of the particles will make sense. Means, as Professor Suchiroji was saying, there are extrinsic properties, intrinsic properties also. But when you analyze the particles through ultimate analysis, what do you mean by ultimate analysis? You cross the border of convention and go closer to the particles, and then you see that the particles are composed of subatomic particles, and then you will agree that none of the subatomic particle is the main particle, and there is no main particle which is different from the subatomic particles. So therefore, particles, when you go closer, examine through ultimate analysis, they do not have any intrinsic nature, means they do not exist intrinsically. Particles do exist but do not exist intrinsically. So particle existing, having mass, charge, weight, this is all the conventional nature of the particle. Whereas when you subject the particles to ultimate analysis to find out how do they exist, then you will see the deeper reality, which is known as ultimate reality in Buddhist perspective, that they do not have any intrinsic nature. So this comes from Prasangika, the highest Buddhist school. They accept particles, like we reiterated, but they do not accept particles to exist intrinsically. So this is, on this note, I'll conclude. It comes from Upali Requested Sutra, again Buddha's words. So where he talks about the emptiness of the intrinsic nature of the physical world. So I read, various delightful flowers blossom, and the sparkling supreme golden abode stands so alluring. For none of these is there a creator. They are posited by the power of thought. It is through conceptualization that the world is imputed. So when you subject the world to be particle or electrons, proton, neutrons to ultimate analysis, they are not found to have any intrinsic nature. But does this mean that they do not exist at all? The answer is no. So Buddha said they are posited by the power of thought. It is through conceptualization that the world is imputed. Nothing exists from the object's side, but things do exist and functions efficaciously by the power of the mental imputation. So with that note, I'll conclude. Thank you.
Thank you very much, Ms. Pooja Dobralla. Now we'll have a quick question and answer session. So we'll take 3 questions because of time limitation, right?
My question is to Professor Satish KS sir. So like you mentioned in your talk that we only know presently we only know about 5% of the universe, and the rest of the 95% we are not aware of, and we have termed it as dark energy or dark particle. So I'm unable to understand this, that when we are not able to perceive something, so how are we able to know that it's still there?
It's not that we are not able to perceive it, we see it indirectly. That is, for example, if you observe the way the galaxies and the stars move in the universe, you know that there is more matter than we can see. So we don't know what that matter is. And the universe is expanding. And the universe is expanding in a way that as you go further away, that expansion is accelerating. It's expanding even faster. For that to happen, there has to be an energy that it uses to push itself out. So these effects are seen, but any conventional theory that we have been able to develop so far does not explain what it is. This matter that we do not see has a gravitational effect on the stars and the galaxies, but nothing else. So we're not able to see it. It doesn't emit light. It doesn't emit anything else that we conventionally see. So we have to just say it's dark matter. That's the way we know it, by its effect on things, gravitational effect on things, but not otherwise.
So, sir, why is it so difficult to not able to understand this
Because
95%?
whatever we see around us, whatever emits light, whatever interacts with us, not just gravitationally, but otherwise also, we know, we believe we understand something of them. In that same sense, we do not understand them. We know they exist, we know they interact gravitationally, but that's all we know about them. And that constitutes 95%.
Dr. Roy, I have a simple question. You mentioned this variation or variable speed of light in different universes, probability distribution of C. So you said could be multiverse. I don't understand this. How you?
No, according to quantum theory,
Yeah.
there is a probability that she can take different values.
Which
Speed of the light
speed of light?
can take different values according to, if we think quantum theory is global theory.
Which
valid
theory?
everywhere.
Which quantum theory?
Normal Copenhagen interpretation.
I haven't heard about it.
No, you should read a very intriguing book by Professor Mittelstadt. He's a very famous German physicist. Recently, he wrote a book called Modern Physics and Ontology or something. He clearly stated all these kind of things.
Okay. I mean, this is not something that
No.
normal physicists believe
no,
in.
because I mean,
We don't believe in that.
Can I ask? Ask her? Yeah. There is a problem when you say. You can check into the Buddhist framework, because when you go to smaller and smaller scale, say quark or Higgs particle or something. Ontologically speaking, there is no particle ontology. In the beginning, or normal quantum mechanics, they say wave and particle. This is the ontological situation. But if you go to the smaller and smaller scale, field and quantum ontology, there is no concept of particle there. So how you will reconcile in Abhidharma and other text? Field concept, I don't know whether Buddhist scholars, they thought of field concept.
I agree with you, sir. This word may not come as a field concept, or I'm sharing my understanding. The electromagnetic field and all, but they do talk about energy, and so the concept of energy is there. Concept of energy moving on a very subtle level. Especially in tantric texts, there is a mention of a very, very subtle energy that moves with the mind, which goes from one life to another. So keeping that things aside, there is a mention of very subtle phenomena such as energy. And then there is no contradiction. So what they say is not that the energy is not there, or now I would will be happy to accept that science, when it comes to the conventional reality of physical matter, they have evolved so much. So we should be accepting that how it is, as sir was explaining, that Higgs boson and the other particles, and especially the entanglement theory and other things. But the question is not about the conventional reality. When it comes to the ultimate reality of this energy also, this quantum, field also, then there is a different method to analyze that how do this exist. Do they exist the way they are perceived as nothing, no role of the mind and the object existing purely from the object side, or there is a that the object cannot exist from its own side objectively. So there the concept of ultimate analysis, the frame of reference is very different. So it would be accepted, the field and the other things, but what is the ultimate nature of these things, then the frame of reference is not the conventional frame of reference.
In physics, we don't have concept of ultimate reality and conventional reality.
Yeah,
That's the whole problem.
that's I agree. But if we understand, I would say I agree with you. But if we understand the nature of these, it's not Buddhistic, to be very honest. Ultimate analysis and
No, which
conventional.
one we say ultimate reality? You say in your experience, you say like Shankaracharya said. I mean, if you to be an enlightened person, for him the Jagat is Maya, it's illusion. So you have to be an enlightened person, then you can understand. But in physics, we cannot say unless you enlighten, you cannot say like that.
In Buddhism,
So methodology is different.
yes, I agree with you, sir. But in Buddhism also, it's not that only when you're enlightened you can perceive the ultimate reality. Way before that, through the inference, as sir was explaining, indirectly using the inference. I agree with your question, but what I'm just as a who is sharing Buddhist perspective, what would be helpful to resolve this is to understand the nature of these two analyses. They are nothing religious or Buddhistic there. If you really understand what do you mean by conventional analysis and what do you mean by ultimate analysis. So I'll just cite what R.N. Nagarjuna said again in this very well-renowned text. What do you mean by ultimate analysis? It simply means, so he cites a very well-known statement from him is, if the mirage were to be water, why not those close by the mirage see the water? So what he said is that if you really want to know the ultimate nature of this mirage, what do? You cannot stay behind, you have to cross the border of convention and go closer to the mirage. Only when you go close enough, and then you see that, okay, it does appear as a water, but it is not water. Then only you realize that what appeared earlier as a water is illusion-like, or it is not intrinsically there. So likewise, he said that all phenomena, if you analyze through ultimate analysis, meaning where you cross the border of conventionality of those phenomena, then you get to the ultimate nature. And then this is done with a purpose, not with the purpose of that, okay, apparatus is such, or we have a limitation. Not, it's to see that, okay, how does the world exist, because it affects our emotional world. And because it affects our emotional world, we should know not only the conventional nature, the way it appears to us, but also the ultimate nature of the world that we are interacting. So with that purpose, these two analyses were explained by Buddha Shakyamuni, and nothing so that's my take. What would be really helpful is to really understand what do you mean, and what is the border of analyzing something through conventional analysis and analyzing something through ultimate analysis, how they are two different frame of reference. Then only we'll be able to see that, okay, this is not something Buddhistic or religious, it's simply two frame of reference that we can use to see the ultimate nature of all phenomena.
No, we are saying ultimate like theory of everything. They think that there might exist like string theories. They say string is the ultimate entity from which you can build up the whole universe. So, but we are not having this kind of concept, that border between conventional and ultimate, because we don't know what is ultimate.
Yeah, but I think if you say that if the ultimate reality is not comfortable for the physicist, then we can say like nature of reality, that is acceptable, right?
Yeah.
So if we can go to understand the nature of reality at that level, then we have to have a different perspective. And that perspective initially has to be developed through inferential kind of processes, and then through experiential processes, and then through meditative procedure, and then eventually, ultimately, not ultimate reality, but ultimately, one can experience that. These are the
That
processes.
is the dreams of physicists like Einstein.
Yeah, and then we are in the same...
Make a theory of everything, but we don't this.
But after all, it is, it has a purpose, as I mentioned in the morning, that to understand the nature of reality. And why it is important to understand the nature of reality is to change our perspective. And to change our perspective is required in order to change our suffering into happiness.
Or do you think it's innate nature of being?
Ji?
Innate nature of being.
Innate has a kind of imposed meaning.
Yeah.
So as you said, really, rightly said that the intrinsic nature. So we have to see, because in Sautantrika they use nature. In Vaibhashika use nature. Sautantrika use nature. Vijnanavada use nature. Madhyamika use nature. All with a different meaning. So we have to understand the context, and then within that context we have to explore and try to understand. Yes.
Yeah, that's a dialogue.
That is why the dialogue is very important, right? Yeah. Yes.
This is for Professor Sisi Roy. Although I'm one of the presenters afterwards, he has given us 3 questions. So for Buddhist scholars, and before I give my own opinion about on those 3 questions, I would like to clarify what we mean by subtlest particle. So subtlest particle means a particle, when you break it down mentally, having the mentally perceivable spatial dimension beyond which you can break further. So that's what we mean by subtlest particle.
No, but our answer is that when we break the particles, we break with the instruments, not mentally we do it.
Yeah, that's why scientific maybe understanding of the waves, particle, energy, whatever it is, our subtlest particle may be more subtler than that. So whatever, even if you don't have the concept of subtle particles, I'm sure when you say waves, particles, energy, they have spatial dimension.
Yes.
So that's...
No, both particle and energy, they have...
So they occupy their own space, spatial dimension. They occupy some space, right?
Yes.
On which other, for example, if it's a particle or a wave, it's its own spatial dimension, on which other wave cannot take their place, right? It's its own spatial dimension.
So this object has also occupied space.
Yeah, of course,
Can
of
I
course,
say this
of course.
is subtle particle?
Yeah, no.
Then?
Subtle means something which does not appear, which is not perceivable to your grosser senses.
Sensory organ.
Yeah, sensory.
No, that's why I
So
say...
because of that, now this one, without using microscope, you won't be able to get to these waves, particles, energy that you have. So
listen, say bacteria. Bacteria we cannot see through our naked eye, but we can see through a microscope. Do you think bacteria is a subtle object?
I'm actually yet to decide whether, when you mean by bacteria, whether bacteria is sentient or not. If it's not sentient, then we have just to consider the physical body of
the... no doubt is there what is bacteria.
So it doesn't matter.
Even a big galaxy. You cannot see through your eye, but a telescope you can see the galaxy. Do you think that is a subtle object?
Well, when you go close to a galaxy, you can see it. That's because of the distance.
Yes.
When the object is close to your eye, even though, for example, this consists of so many particles.
Yeah.
The subtlest particles, even if you take it close to your eyes, you won't be able to see them.
No, that's why I say that sensory eye plus instrument. This is in science.
Yeah, so we don't use instrument together with that. All right, so that's what we, if I may answer, what is the difference between gross matter and subtle matter? That's one of the questions. So gross matters for us, Buddhist philosophers, are those which are beyond our senses.
Okay.
And then subtler are those which are beyond our senses, and gross are that are perceivable to our senses. Now, another thing is, you said the subtlest waves and so forth, they have their own intrinsic property. And in Buddhism, you don't accept any intrinsic nature of any phenomena. So how do you reconcile these two? So in my own understanding, when you get to the intrinsic property of the subtlest wave, you get to that by using your microscope, and then you see that intrinsic, the word intrinsic, if I get it properly, you mean to say that intrinsic property means the property which is inseparable from that wave, which doesn't change. It's inseparable. It's inherent part of that particle. So that's for that you're using the word intrinsic. Whereas in Buddhist philosophy, when we say nothing exists intrinsically, of course the particle, the wave, energy, everything, as you accept to exist, we accept. But then they do not accept from the side of the object. There are two possibilities. Either they exist from the side of the object or by subjective imputation. If you try to find out them from, try to pinpoint them, a concrete locus you won't be able to find. That doesn't mean that they don't exist.
No, I
agree. So their existence is from the side of the subject and not from the object.
No,
that's why we say they do not exist intrinsically or from their own side. But there is no contradiction. So
there is contradiction in the sense that even His Holiness Dalai Lama said, if modern science proves something, then we should be open to accept it.
Yeah.
Now, in our case, in science, we have shown that no, the electron has intrinsic property like charge. You cannot get another electron by converting this electron to that entity.
Yeah, that's okay. For example, the impermanent nature of us, that's also inseparable. So that's also an intrinsic property, even if we are gross.
No, we are not saying that earth has intrinsic property. In philosophically, we say solidity and something.
All right. And anyway, I think we just need to get different connotations of what intrinsic means. Then you said, okay, the relation between two electrons, two protons.
Yeah.
So there is a relation between these two. And as per Dhammakiti's understanding or positing of two kinds of relation, it doesn't fall within any of these two, which is true. And we do not subscribe to the ultimate reality as proposed by Dhammakiti. For example, the relation. So the definition of relation is if two things. Okay. First, we have to see if when we are speaking of relation of two different entities, whether they exist simultaneously or subsequently. So if this occurs subsequently, then if because of the cause being becoming non-existent, if the result cease to exist, that means the cause impacts the existence of the.
No,
That's what I'm saying. Existence of the result is dependent on the existence of the cause. That's why they are related. Now, if they exist simultaneously, for example, this mass and its color. Okay, if also impermanence nature of this mass and this mass. So, if this mass exists, the impermanence nature of this mass exists. If this mass impermanent exists, it exists. But if the mass stops to cease or stops to exist, then its impermanent nature will also cease to exist. So because of that, even though we can say impermanence, that is the quality of this mass and the mass, there are two things that exist simultaneously and they impact one another. Because of that, they are related. So from that perspective, we cannot say two protons. If they impact one another, because of which if one proton's non-existence or cessation of one proton will cause the cessation of the other proton, then we can say they are related.
Otherwise,
No,
because
this happens because if we measure the property of one proton, then immediately you can say, even without measuring, what will be the property of another proton far away from this. So this is not causal relation, because you know nature of the relation. Apart from causal relation, there may be other type of relation.
okay, that's true. Yeah, that's true. Yeah, thank you.
Hello. Hello, sir and ma'am. I have a question. In all these talks about intrinsic quality and emptiness, I wanted to ask if we are really talking about the duality of mind and body, are we separating both, like separating the mind and the matter that's making up the body? And with that, I want to ask if it is really separate from the physicalism of physics, which thinks of the world as a physical object, as a something coming about from the interaction of forces and matters. Why can't the mind itself be thought of as a natural product of the psychological and physiological and neurological faculties that we have as a human being, and probably other animals do have too?
Okay, this is very interesting question. I can end this with a very small story. When I was in USA, on my side of my office, one very famous neuroscientist, his name is Carl Pribram, who proposed holographic theory of brain. He used to come to my office once in a week, and he had only one question to me. Shishi, tell me, where is my mind? And he believed that it is in my neuronal architecture. So we don't yet, as a physicist, we don't know what is mind. That I can tell you. Then mind-body problem comes later on.
Thank you very much, everyone. And that was the last question. So I would like to thank Mr. Chairperson Venerable Gishing Samdela and the respected guest speakers. And I would like to request Mrs. Joya Roy Ji to kindly do the honor and present the souvenirs and the white scarf to our chairperson and our guest. Please welcome Joy Roy Ji. Venerable Gishing Samdela, Joy Ji, I would like to request you to kindly offer the scarf to Venerable Gishing Samdela. Thank you very much. And then we have Professor Sisi Roy Ji. And now we have Professor Satish KSG. I would like to request to kindly offer the souvenir and the white scarf. And now we have Dr. Pooja Dabrala. I would like to make a quick announcement, Gishla. We'll have a quick photo session on the stage. So, just now, sir. At the end of the day, or we have already concluded, sir. Okay. Right. No. We have a quick tea break session for 15 minutes, and afterwards we'll resume the last session of the day. Thank you very, very much, everyone.